This question is from Coulomb's law in electrostatics, which was asked during the year 2024 January JEE exam. The question says there are 2 point charges, Q1 and Q2, kept in vacuum at a distance r apart. They experience a force F. Now they wanted the force between the two charges when it is kept in a medium of dielectric constant 5 at a distance r by 5. The rule that we are going to use is Coulomb's law in electrostatics, which is F equals 1 upon 4 pi epsilon 0 Q1 Q2 over r square. Because of change in dielectric constant, the force between the two decreases to 1/5. And since distance between the two reduced to 1/5 of the previous value, the force between them changes into 1 over 5 the whole square of the old force. Physics is over. Now math, when you rearrange 1 over 5, this becomes 1 upon 1 over 25. It becomes 25 over 1. And the old force is just F. The final answer becomes 5F. So the answer is B. This is from NEET 2020 based on Coulomb's law in electrostatics and Newton's second law. The question asks you to find the acceleration of an electron due to mutual attraction between an electron and a proton when they are at a distance of 1.6 Armstrong. For first, we have to convert Armstrong into meter times 10 to the power of minus 10. And then we have to find the force between the two charges. The force between proton and electron can be calculated using the equation F equals Q1 Q2 over R square. The value of K, 9 times 10 to the power of 9. Q1, charge of an electron, which is 1.6 times 10 to the power of minus 19. Q2, charge of a proton, 1.6 times 10 to the power of minus 19. Separation between them, 1.6 times 10 to the power of minus 10 the whole square. 1.6 on numerator cancels with the 1.6 square on the denominator, and the remaining thing is 9 times 10 to the power of 9, then minus 19, another minus 19 divided by minus 10 the whole square becomes minus 20. When it goes to the top, it becomes plus 20. All cancel. Final answer becomes 9 times 10 to the power of 9. To get acceleration by Newton's second law, F equals ma. So A will be F over m. The value of F is 9 times 10 to the power of 9. And the mass of electron is 9 times 10 to the power of minus 31. Final value becomes 10 to the power of 22. So the final answer is D. This question is from Coulomb's law in electrostatics, which was asked for JEE 2022 June. The question says there are 3 identical charged balls, each of having a charge 2 coulomb, suspended from a common point P by 3 silk threads, 2 meter long. 1 silk thread, another silk thread, and the third silk thread. If you view from the bottom, all of them look like an equilateral triangle of side 1 meter each. What they wanted is a ratio of net force experienced on one of the charges from the other two to the force between any two charges. To do that, if you view from the bottom of the silk threads, you feel the 3 charges will be at the 3 corners of an equilateral triangle of 1 meter side. Let's find the force experienced on one of the charges from the other charge. For that, we have to use Coulomb's law in electrostatics. K, Q1 Q2 over R square. Plugging the values, K is just taking K itself. Q1 is 2 coulomb. Q2 is also 2 coulomb. Separation between the two 1 meter. It gives you 4K. Now, in the same way, the force on the same 2 coulomb from the other charge will also be just F. Since it is an equilateral triangle, the angle between these two sides will be 60 degree. So this will also be 60 degree. What to do next? We have to find the net force experienced on one of the charges from the other two. By vector rule, net force experienced will be P square plus Q square plus 2PQ cos theta. Plugging the values, value of P, we just take it as F. So it will be F square plus another F square plus 2F cos, the angle between the two is 60, and we know cos 60 is half. This two cancels, remaining will be F square, another F square, another F square, so total 3F square, all inside the square root, which will give you root of 3F. And what do they want is F net divided by F, which is just root 3 over 1. So the final answer will be D. This question is also from Coulomb's law in electrostatics in combination with quantization of electric charges. This was asked for JEE 2024 April. The question says there are two identical spheres P and S with each having a charge of Q, and they repel each other with a force of 16 Newton. You have another third but uncharged conducting sphere. We call it as R. What we do with R, we successively brought in contact with the first two spheres, which means R is kept in contact with P first, then R is kept in contact with S next. Then we have to find the new force of repulsion between P and S. For this, we have to use Coulomb's law in electrostatics, which is F equals K Q1 Q2 over R square. So let's see what is happening. They initially, P and S, initially they repel each other with a force of 16 Newton. What we do is we bring the third charge R, which is kept in contact with P. P has a total charge of Q. R has no charge. Once kept in contact with each other, the total charge they share, so each one will have a total charge of Q by 2. Then what we do, we move R and kept in contact with S. Q of S and Q by 2 of R added together will give you 3Q over 2, and then they share among the two. Each will have a total charge of 3Q over 4. Then we bring P and S together. We knew P had a total charge of Q by 2. S has a total charge of 3Q over 4. Distance between the two stays the same. What is the force between these two charges? By the rule, the new force will be the old force, which is 16 times, since the charge reduced to 1/2, the force has to become 1/2 of the old value, and again S is also became 3/4 of the old charge. So the force again reduces to 3/4 of the old value. So altogether it becomes 16 times 3 over 8. These two cancels. Eventually that becomes 6 Newton. So the final answer will be B. This question is based on Coulomb's law in electrostatics and upthrust in fluid dynamics. This was asked during the year 2024 Jan for JEE. The question says two identical charged spheres are suspended by two strings of equal length. The strings make an angle theta with each other when it is kept in air. When we do the same underwater, the angle between the strings remain the same. They have given you density of the steel ball 1.5 gram per cubic centimeter and density of water 1 gram per centimeter cube. They wanted dielectric constant of water. For this, let's draw a picture. We call it as kind of free body diagram. And in this picture, you can see the two steel balls, the two threads, they repel each other with a force F. The steel ball experiences its weight mg in air and it experiences tension. We can resolve, and it's given the angle between the two strings is theta. I can resolve the tension into two components. Now this angle is half of theta, theta by 2. Since this is the opposite side, t sine theta by 2, which balances F, and the adjacent component t cos theta by 2 balances mg, which is written over here. F is balanced by t sine theta by 2 and mg is balanced by t cos theta by 2. We have to eliminate t. For that, we take the ratio between the two. F over mg, sine theta by 2 over cos theta by 2 gives you tan theta by 2. The question says when we keep these two steel balls under water, the angle between the two strings remain the same, but the steel ball experiences an extra force, which is upthrust, which depends on volume of the steel ball, density of water sigma, and g, the acceleration due to gravity. And now the repulsive force between the two becomes F dash. Since the angle stays the same underwater also, the equation remains the same with only one difference. In place of F, now it is F dash, the force between the two steel balls underwater, and mg dash, which is the apparent weight of steel ball under water. Since RHS of these two equations remain tan theta by 2, we can equate LHS. We can cancel m, and rearranging it as F dash divided by F equals g dash divided by g. By the rule, this is equal to K, the dielectric constant of water, because the force between the two charges underwater divided by the force between two charges in air will give you the value of K, which is dielectric constant. Our next task is to find the relation between G dash and G in terms of densities. For that, let's find the apparent weight of steel ball underwater, which is mg dash. If you look at this picture, these two forces are in opposite directions. So a resultant will be the difference between the two, which is mg take away v sigma g, which will give you the apparent weight of steel ball under water. What we do next is the mass of the steel ball can be replaced by the volume of the steel ball into density of steel ball, which is v rho. So replacing m in both places by v times rho, volume of steel ball, times density of steel ball. And you can see here everywhere there is v, which can be cancelled. Next, what we do is we divide the entire equation by rho, density of steel ball. Rho cancels, so it will give you g dash equals g take away sigma g divided by rho. Since g is common, take it out, so it becomes g times 1 minus sigma divided by rho. Rearranging to get g dash divided by g, which we are looking for, equals 1 minus sigma divided by rho. Comparing this with this, we got an expression for K in terms of the densities of water and the steel ball. So K equals 1 minus sigma divided by rho. Sigma stands for density of water. Rho stands for density of steel ball. The calculation gives you 3. So dielectric constant of water is 3.